So today we're going to look at a system of measurement that we're going to be using in class. The more common system that you're probably familiar with is one where we use ounces and pounds, but this is not very user-friendly when it comes to doing calculations. So the system that we use is actually called the metric system. Within the metric system, you're going to be using things like grams to measure mass, and to measure volume, you're going to use things like liters. Now, both of these are considered base units. These are the units that you're generally going to use for mass and volume. However, we can change the order of magnitude that we're talking about using different prefixes. So these are prefixes you've very likely heard of before. Kilo means 1,000. So if, for example, we have kilo, this prefix, in front of grams, we have 1 kilogram, that means that we have 1,000 grams. Milli, on the other hand, means 1/1000th. It's a fraction of whatever the base unit is. So if we're talking about liters, 1 liter is going to contain 1,000 milliliters. Now, these are only a couple of the prefixes that we're going to talk about. We have a list that we need to learn for the final exam, which we will do in class. So don't get too frustrated with this just yet. I'm just trying to give you a little taste of it. Right now, what we're going to do is look at some measuring instruments that we can use. Now, the idea in chemistry is to use the most precise piece of equipment possible, depending on what you're trying to measure. So I'm going to show you a couple of different tools that you can use, and we'll talk about how precise each of those tools can be. Now, what you're looking at now is called a triple beam balance. This is something that's going to measure mass. You can certainly tell here it says 610 grams, so grams are used for mass. If you look at it from the top, you can see that there are 3 beams. All right. Each beam has a weight on it. So the front beam has a small weight on it, the middle beam has a much larger weight on it, and the one in the back has another medium kind of sized weight on it. The first thing that you have to notice is that when there's nothing on the scale, the line here must match up to the 0 here. And right now it's fluctuating a little bit because I've been moving it, but it'll rest on that 0. Now, if we want to weigh something and figure out how many grams it weighs, let's see, we can weigh this beaker. All right, there's nothing in it, it's completely empty, but we can weigh this beaker. So we'll put it on top of the scale, on top of the balance, and what we're going to do is just shift these weights until that line meets up with the 0 again. So I have no idea how much this little beaker weighs, but it definitely weighs more than 10 grams. So at this point, what I would do is put that all the way back to 0, and in the back, there's a 10-gram weight. Now, I've moved it over to 10 grams, but it still didn't budge right here. So I'm going to move it over another 10 grams. Still didn't budge. So we know that this beaker is at least 20 grams. Another 10 grams. Oh, now it's moving. What we want to see, is it going to actually reach and end at that line? It doesn't look like it is. So what we would do is I would use the little one to see, all right, how much more do we need? Close. All right, so now we've got the lines matching up, And the way I would read this measurement is in the back we have 30 grams, plus in the front we have about 3/10 of a gram. So I would say that this was 30.3 grams. So this little beaker, without anything in it, weighs 30.3 grams, according to this triple beam balance. Now, we also have electronic balances like this. We'll use these occasionally when they work. And let's see what our triple beam balance says about this beaker. It says that it is 31 grams. I don't know that you can see that. Okay, it says 31 grams. Now, this balance is not going to give you decimal places. It is not precise enough to do that. So in this case, we have a much less precise measurement for the mass of this beaker than the triple beam balance gave us. Now let's look at some tools for measuring volume. Now, we're going to have several different sized graduated cylinders. Okay, so this one is a 100 milliliter graduated cylinder. This one is 50, and this tiny adorable one is 10. If I were to ask you to measure something out and I wanted you to give me 8 milliliters of it, there's no reason for you to use this. 8 milliliters would be right there, and you wouldn't be able to get as precise as you would with this one, where you can actually see the lines for tenths of a milliliter. Okay. All right.